I thought they got 3. Okay, yeah. Yeah. All right. All right. All right, are we ready? All right. Okay, let's go ahead and get started. Okay, we are doing day 1 of a new topic. We are learning implicit differentiation today. Okay, and the IM on implicit got hole punched. So if you want to just squeeze in, that's implicit differentiation. Here's when you need implicit. Look at the equation for number 1. Will you just take like a little peek at it? Do you see how the equation for number 1 right here, how the X and Y's are all kind of garbled and it's not like Y equals and then an equation? Okay, this is when you need implicit. So let's go up to the top and let's fill in. Implicit differentiation is a method used to take derivatives. Okay, when you cannot solve for Y equals. So if all your X's and Y's are kind of squished together in the equation, implicit is how you take the derivative of that. Okay, there are 5 steps, and we're going to fill them out as we go. So step number 1 is you are going to take the derivative on both sides with respect to X. Now, derivative with respect to X is the same thing that we've been writing ddx. Okay, that already means derivative with respect to x. But here's the thing, because x is your main variable, anytime that you take the derivative, thank you so much. I'll send him, thanks. Anytime you take the derivative of something where y is your variable, you're gonna have to add a dy dx to the end of that term. Okay, so let's take a look at number 1, and now we're gonna do it. Okay, I'm gonna take the derivative on both sides. Anytime that I have a y, I'm gonna have to put a dy dx. Here we go, look at number 1. Okay, I'm gonna rewrite my equation here. Cosine 4x plus 2y squared minus e to the x equals 8. And then on both sides, I'm gonna put d dx, which means that we're taking the derivative. Okay, but remember, if you take the derivative on one side, you have to also do it on the other side. Okay. When you take the derivative, you should have done your chain rule notes for homework. What the chain rule says is if you ever have a function plugged into another function, you take the derivative of the outside layer first, inside layer second. So that's going to come into play right here. What is the derivative of cosine? Negative sign. And then the chain rule says that you keep the 4x the same, but then you times that derivative behind it. So if I do negative sign of 4x, what would the derivative of the 4x part be? Times 4, that's what chain rule says. Okay, plus. Next term, I have a 2y squared. What would the derivative of that be? Okay, plus 4y. And now my y would be to the first power. But because it's a y instead of an x, I have to put a dy dx on it. Anytime it's a y, you're going to do that. Okay, next term is minus e to the x. What is the derivative of e to the x? E to the x again. Okay, equals. Then on the other side, I just had an 8. 8 is a constant. What's the derivative of a constant? 0. Okay, step number 2, go back up to the top. You are going to separate any terms that have a dy dx are going to stay on the left. Any terms without a dy dx are going to go to the right. Okay, so anything with a dy dx is going to stay on the left. Anything that does not have one is going to go to the right. Now, when I say terms, I want to make sure that you understand what I mean. Okay, a term is going to be something added or subtracted with other stuff. So if I'm looking at this equation, this has 4 terms. I'm going to underline them for you. This is a term. This is a term. This is a term. And then 0 is a term. Okay, actually, maybe instead of underlining, I'll box them. So I have term number 1 plus term number 2 minus term number 3 equal to term number 4. So out of all of those terms, only dy dx terms get to stay on the left. Who are we moving? Does the sine 4x times 4 have a dy dx in it? Then it's got to move. Does the e to the x have one? No. So these are the 2 terms that we're going to move. We're going to add the sine 4x times 4 to the other side. And we're going to add the e to the x to the other side. So that now we have a plus 4 sine 4x and an e to the x. Okay, and now this is crossed out and crossed out. Okay, look at that, kind of see if that makes sense. So any terms that don't have a dy dx, you got to push them across to the other side. Notice that my sign used to be negative. Once I flip it over to the right, now it's a positive 4 sign. And my e to the x used to be negative, now it's positive. Okay, so here's what we have so far. 4y dy dx equals. And then I had a 4 sine 4x plus e to the x. Okay, your last step, this is step number 4. We are skipping step 3, is going to be to divide to get the dy dx by itself. So my dy dx has a 4y multiplied with it. So to get rid of that, I'm going to divide. So divide 4y, divide 4. And there's your equation. Dy dx equals, okay, this crap right here. Now, that fraction, okay, tells you the slope at any point that you want. So this is the slope at any point that you want. But there's one thing that is very different than all the other derivatives that we've done in the past. Normally, your derivative only has an x in it. So when you're trying to find the slope at a point, you only need the x value. Okay, I want you to notice that for this dy dx, it has x's and what? It has a y. So I can't just plug in 5. I need an x and a y value now for me to be able to find slope. So let's come over to part B. It says, find the slope at the point 0, -2. Remember what I just said, you need both of those numbers or you can't plug in. So here's the notation, then we're gonna plug it in. If you want the slope at a point, you're gonna do dy dx, a vertical line, and then you're gonna write what that point is. Okay, so write that up here at the top. Dy dx, a vertical line, and then the ordered pair that you're plugging in has to have both an x and a y. Now let's do it for part B. So I want dy dx, vertical line, 0, -2. Okay, so see if that makes sense right there. Dy dx, vertical line, 0, -2. And then when I plug in, 0 is going in for all of my x's, -2 is going to go in for all of my y's. I'm using this formula right here. So it's 4 sine 4 times x is now 4 times 0, plus e to the x is now e to the 0, all divided by 4y is now 4 times -2. What is 4 times 0 in the parentheses here? 0. And then can you tell me what is the sign then of 0? 0. So that whole term right there basically is just going to go to 0. Now, will e to the 0 also go to 0? No. What's e to the 0? 1 over, and then on the bottom, what's 4 times -2? -8. That is the same as -1/8. Okay, you can put the negative specifically into the bottom, but remember that a negative in the front is just as well, and you're more likely to see it like that. Okay, last part of this question says, write the equation of the tangent line. What are the 2 pieces or ingredients that you need to write the equation of a line? Point and a slope. And now we have both of those, right? My point is up here. Okay, it's 0, -2. That's the way. Okay, and then my slope is going to be -1/8. So I'm going to rewrite those pieces here to remind myself of what I'm considering. Okay, it was 0, -2, and then my slope was -1/8. So put y blank equals blank x blank. And then remember, into the blanks, we're going to put the x and the y values, and we're going to put the slope. So my x value was a 0. I'm going to put -0. My y value was a -2. I'm going to put a +2. My slope was a -1/8. I'm going to put -1/8. Okay. And then remember that for your delta math, Okay, this is good enough. The only time you would have to put that into y equals mx plus b is if it was like on the AP test and you're trying to match a multiple choice question. Okay, but other than that, this is good enough. Okay, go ahead and turn the page for me. It was a big curve. It was a square root curve. But there were, I'd say, 2 questions on it. You didn't really have much of a fair chance. So that was why I did a bigger curve. All right, take a look at number 2, please. Okay, number 2. We have sine 2x plus 3y squared minus 12 equals 5x. Okay, step number 1. You need to take the derivative with respect to x on both sides. So I'm gonna dx over here, and I'm gonna ddx over here. Okay, let's go one term at a time, starting with sine 2x. What is the derivative of sine? Cosine. And then remember, chain rule says you're going to keep that core the same, but then you're going to times its derivative behind it. So if the core is a 2x, what are we going to multiply behind that? The derivative of 2x is an extra times 2. Very good. Plus. Next term was a 3y squared. What's the derivative? 6y, but then since it was a y, what do I have to put? dy dx. What about the minus 12 goes to what? 0. Okay, then I go to the other side. I had a 5x. What's the derivative of 5x? Just a 5. Okay, then from here, anyone who does not have a dy dx, we're going to push across to the other side. Who are we moving? Okay, the cosine 2x times 2 is going to have to go across to the other side. Now notice 5 also doesn't have one, but it's already on the right-hand side. So we don't have to move it there because it's already on the side it needs to be on. So here's what we have so far. 6y dy dx equals, I already had a 5, and now I have a minus cosine 2x times 2. And then actually, I don't like the 2 at the back. I'm going to move it to there. Okay. But notice cosine 2x times 2 and the 2 in the front, it's the same thing. Okay, last step. After I get everything separated, how do I get rid of the 6y in the front? Divide by 6y. Very good. So 6y here, 6y here. This equation is the derivative, which will tell me the slope at any point that I want. Okay, but notice that we're using the word point very specifically. It's not at any x, it's at any x and y, because you have to have both. So let's go ahead to part B. Okay, we're going to add several pieces in these next few questions. Okay, we want to find the point where x is 0. So go back to your first page for me. If they give you part of the point, but not the whole point, okay, go to step number 5. Okay, it says use the original equation when you need to complete the xy. Okay. Use the original equation to complete the xy. So if they only give you the x or only give you the y, that's not going to work. You have to have both. So the original equation is where you'll get the other half of that point. So now return back to question number 2 and let's do it. They're telling me that I want my x to be equal to 0. Then I'm not going to use this. I'm going to go back to the original. So in the original equation, plug in a 0 where your x is, we're gonna solve for y. So I'm gonna put here, use original equation. So it was originally assigned to x. Now it's assigned 2 times 0 plus 3y squared minus 12 equal to 5x is now 5 times 0. 2 times 0 in the trig gives me how much? And then what is the sign of 0 we said? 0. So that whole term is gone. Then I have 3y squared minus 12 equals. Okay, that is going to be a 0. Okay, can you finish solving that out? So add the 12 across, blah, blah, blah. What are we going to end up getting? Good, kind of. So 3y squared is 12. Divide the 3. What am I going to get? Y squared equals 4. Then why did I say kind of on 2? Plus minus. Very good. Okay, so I have that y equals plus or minus 2. Now, go back and look at the top of this question. It says what? Find the point where my x is 0. I have 2 choices, but then I want the one where my y is greater than 0. So who am I going to pair it with? Positive 2 or negative 2? Positive. So they're telling me right here that I need to choose 0, 2 as my point. Okay. All right, then in the next part, it says, all right, now that you have your point, part C says, find the slope. So remember, slope, you're going to take that x comma y, you're just going to plug it in. Remember your notation, though, it's going to be dy dx, vertical line, 0, 2. And then we're going to plug it in. So what this means is the slope at the point 0, 2. So I have 5 minus 2. Cosine 2x is now a 0. And then over 6y is going to be a 2. Okay, 2 times 0 is 0. What is the cosine of 0? It is 1. Very good. So remember, this is going to cancel out to a 1. So I have 5 minus 2 times 1 is 5 minus 2. How many did we get there? 5 minus 2 is 3. And then 6 times 2 on bottom is 12. So that's going to go to 1, 4. Okay, go ahead to part D. We're asked to write the equation of the line. What 2 ingredients do you need to write the equation of a line? Okay, point and a slope. Very good. Okay, our point is 0, 2. Our slope is 1/4. Then we're ready to write the equation of our line. Go ahead and do it for me. So I have y minus 2 equals 1/4 x minus 0. Okay, for the AP test, sometimes they'll ask you just to write the equation. Sometimes they'll ask you to use it to approximate f of some decimal. Okay, if they ask you to do that, all you need to do is take whatever this x is and plug it in right there. So they're asking you to find f of 0.1. Then you're just going to plug 0.1 into your x. Okay. So I have y minus 2 equals 1/4. This is now 0.1 minus 0. Okay, so not only are we writing the equation of the tangent line, but now we're using it to do an estimation. We're just plugging that value in. Now from here, what is 0.1 minus 0? It'd still be 0.1. Okay, and then the problem that we're gonna run into is that we have a fraction and we have a decimal. So really, we need to pick one rather than having one of each. So is 1/4 easily converted into decimal? What would that be the same as? Okay, 0.25. Very good. And now when you are multiplying any number times 1, do you know that it stays the same? 0.1 is going to stay the same, but you're going to bump the decimal. Okay, one spot forward. So this is going to be y minus 2 equals 0.25 will now be 0.025. Okay, so the times 1, the number stays the same, but you just bump the decimal one spot forward. Okay, and then from there, how do I get rid of the minus 2? Plus 2. So it'd be y equals 2.025. Okay. So you should be able to write the equation of a tangent line. Then you should be able to plug in whatever value they say. Okay. Got it? Okay, we're going to skip around a little bit. Go to number 6, please. Okay, question should look like this. Okay, give it a shot. You can do it. Number 6. I thought you were gonna say like ADHD or something. A whole year? This woman didn't help today. It's fine. Wow. All right, we ready to start number 6? Okay. Now remember, if you take the derivative of a y, what do you have to put? Y dx. Okay, don't forget that. Yes. Okay, just do your first step. Huh? This had a y, so it should have it. Now the x word doesn't.
This has to be right.
Correct. You wait till this one's over. Okay, let's see how you did. Okay, you're taking the derivative on both sides. What is the derivative of 2y cubed? 6y squared dy dx. Okay, minus 3y squared. What's the derivative? 6y what? dy dx. Minus 12y. What's the derivative? dy dx. Now, even though it had a y and we dropped it down to a 0, if it had a y, that still counts. Okay, next term was a minus x squared. What's the derivative? 2x. Does it get a dy dx? No. No, because it was originally already x. Last term is an equals 0 because it was a 2. Okay, from here, any term that does not have a dy dx has to go to the other side. Who are we moving? It was a minus 2x, so when I move it over, now it's a plus 2x. Okay, from here. Okay, look at all of your terms that are going to stay. All of them have what in common? They all have a dy dx. So here's the step that we've been skipping. Go back to your front page. Step number 3. Okay, step number 3. If you end up with multiple dy dx terms, you are going to GCF and factor your dy dx out. Okay, you will only have to do this step if you end up with multiple terms that all have a dy dx. Okay, so step number 3 that we've been skipping is if you get multiple dy dx's, you're gonna have to GCF it out. Then what's the next step for number 4? Divide. So let's do it now on number 6. Okay, so I'm gonna GCF my dy dx out to the front. Now, someone in my other class had said, well, can I also take out a 6? Okay, you could, but don't. Thank you. So my dy dx comes out. Now I have a 6y squared. I have a minus 6y and a minus 12. But when I divide, I want to keep my dy dx to be equal. So I'm going to divide this entire parentheses across to the other side. Okay, so there's your equation. Okay, now I'm going to rewrite it over here to the side. So it's a 2x on top over a 6y squared minus 6y minus 12. And then remember that if that's dy dx, that's the slope at any point that I want. Slope at any point. Okay, and if I want to know the slope, I just need an x and a y. I can plug it in. That'll give you my value at that spot. Okay, now 2 new questions. Look at parts B and C. What if instead of me wanting the slope at a point, what if I want to know where the slope is horizontal? Do you remember what slope that means that I want? A 0 slope. Very good. So if you want a horizontal slope, you are going to take the derivative and you're going to set the top equal to 0. Now, I want you to think about why we would set the top equal to 0. Because 0 divided by anything gives me 0. Now, look right next to it at part C. What if I want it to be vertical? What kind of slope does a vertical line have? Similar to D&E, but that's for limits. Undefined. Very good. So I'm going to set the bottom equal to 0. And the reason why is that if I get something over 0, that's undefined. That's what I want. Okay, so remember that a horizontal slope is a 0. I need the 0 to come out on the top. Versus a vertical is an undefined slope. I need the 0 to come out on the bottom. So now let's do that. Here's your equation. Notice it's a fraction. It has a top and it has a bottom. The top finds horizontals. And the bottom finds verticals. Okay. The top equal to 0 finds horizontals. The bottom equal to 0 finds verticals. Okay, let's do horizontal first. If 2x equals 0, what do I need to do to solve? Okay, and what is 0 divided by 2? X equals 0. Now, if your homework says to find the points, you need to give an X and a Y. If it says describe the points, this is good enough. You would say any point with X equal to 0. Okay, but you're not actually having to find the Y's that go with it. You're just saying if the X is a 0, it's going to come out horizontal. Okay, now let's do our vertical. How many answers do we anticipate getting if this is quadratic? 2. What do we do first before we AC chart it? GCF the 6 out. Very good. So my 6y squared is now just 1y squared. My 6y is a minus 1y. And my 12 is now 2. Okay, think about how we can factor that. I need numbers that will multiply to 2 and have a difference of -1. -2 and 1. Very good. So I have y minus 2 and y plus 1. Okay, and then remember from there, that means my solutions are the opposite of what those parentheses say. So if it's a -2 here, then I would say if my y is a 2, and if my y is a -1. Okay, then to make it a describe, you would just say any point where, any point, so y is 2 or -1. Okay, but you don't have to find the whole point because you're just describing it. So just an X or just a Y, that's good enough for a description. Okay, does that kind of make sense? A little bit? Okay, we really need to do probably 2 more, but I'm gonna give you a minute to start your homework. So will you pull out some scratch paper? And we'll do a few of the level 1s only to make sure you kind of have the idea. You want paper? Just do level 1 only, level 1 only. Would you like the paper? Anybody else? Level 1 only, level 1 only. Yeah. So don't sweat it, but in your notes. Okay, I would love for you to please turn to number 3. Okay, go back to number 3. Okay. All right, are we ready? Okay, I would love for us to make an effort to not like talk the whole time we're doing notes. I would really love that. I know some of you are just quite bright that one example is enough, but I don't think for everyone that's the case. And so let's just try to run through maybe 2 that have product rule. And then we'll be back to doing homework. And if you need any help with that, I can answer questions individually. Okay, number 3. Look at the first term. Do you see that it has X's and Y's mixed in together? Okay, you need to use product rule anytime that happens. So for this first term, I'm going to put PR for product rule. And like I said, the reason product rule is required is because it's not just 3y squared or 2x cubed. It's X's and Y's together. So for product rule, your U is going to be the 2x piece. Your V is going to be the y cubed piece. What is the derivative of 2x for my u prime? Okay, just the 2, that is correct. For my v prime, I want the derivative of y cubed. What would that be? 3y squared what? Thank you, dy dx. Very good. Okay, so now I'm going to write the derivative just for this piece. It's going to be this plus this. Now, if you want to, as you go, you can go ahead and, like, for this diagonal, times the 2 and the 3 together. So what would 2x times 3y squared be? 6xy squared dy dx plus, and then my other diagonal is just a 2 times a y cubed, so it'd just be 2y cubed. Okay, but notice that all of that stuff you just wrote is only the derivative for this one term. Now we still have to keep going through the rest of the equation. So my next term was a minus 4y. What's the derivative of that? Minus 4 dy dx. Then I have my equals 6. What's the derivative of equals 6? 0. Who does not have a dy dx that has to relocate? The 2y cubed, right, is going to have to push across to the other side, and it's going to turn to a what? Okay, negative 2y cubed. Now, one other thing, I want us to try to start doing this step together now. So we pull this across. Now let's go ahead and take the dy dx out in the same step. So dy dx parentheses. And then I'm going to take out the 6xy squared. And then the minus 4. Okay, then we know that term ends up where when we solve it? Underneath, because we have to divide to get it there. Okay, so 6xy squared minus 4. 6xy squared minus 4. Okay. And remember that that is your slope at any point x comma y. Now, when you get into the level 2s, it's going to involve product rule, but it's also going to require you to finish the point out for yourself. So take a look at part B. It says, find the point where y is 1. Where do I find the other half of the point? In the derivative or the original? Okay, so very good. Anytime that you see point, remember, you need to use the original equation for that. So I'm going to go back to my original equation. I'm going to plug in my y to be a 1 and then see what x would have to be to go with it, because I need a full x comma y to plug in. So it's 2xy cubed is now a 1 cubed minus 4y is a 1 equals 6. Okay, we know to follow PEMDAS, 1 cubed is 1 times 2x is 2x. 4 times 1 is 4. What would my next step be? Plus the 4 first. 6 plus 4 gives me 2x equals 10. And then divide that 2 across. Now we know that our x has to be a 5. Okay, but you cannot plug in just an x or just a y. You have to have both by the time you get to the derivative. So then down here for part C, it says write the equation of the tangent line. Now I have my full point, 5 comma 1. What's the other ingredient that I need besides the point? The slope. Okay, and remember your notation on that is y dx, vertical line, 5 comma 1. And then you're plugging in to your dy dx equation, which is the kind of ugly fraction. So I'm going to have a negative 2 times y is a 1 cubed. 6 times 5 times 1 squared minus 4. What's the top of that going to be? Minus 2. And then on the bottom, 6 times 5 times 1 squared is 30. Take away 4 would be 26, which will go to negative 1/13. Okay, then you should be able to write the equation of the tangent line if you're asked to do so. So it would be y minus 1, negative 1/13, x minus 5. Okay. So it's kind of a lot going on, but I feel like some of it is old stuff and then some of it is new. Okay, will you turn now to number 4? And tell me which part of number 4 is going to require the product rule. Okay, give it a shot. Your u should be an x squared. And your v should be a sine y. Okay, this very first term is going to require product rule. So give it a shot. So your u is the x squared. Your v is the sine y. And then go ahead and solve all the way to the dy dx spot. Negative cosine. Oh wait, no, I'm wrong. You're right. It is just regular cosine. And then don't forget. Correct. Cosine y what? Dy dx. Yes, very good. Then put your crossfires and then don't forget the rest of the equation behind. So remember, product rule is just that first part of the derivative. You have to finish the equation, yeah? Because that was the original. Remember, here we hadn't taken the derivative till we got to the. Okay, so do this plus this is the dy dx on it. Add what? Yeah. And now keep going through the equation. So then next it's a plus 2y, once the derivative of plus 2y. Plus 2, and then x equals, what's the derivative of x plus 6 on the other side? Yep. And then 6 would go to these. Okay, then from there, anything that doesn't have any y dx, so that's sign is going to be subtracted from. All right, you should have this x squared cosine y dy dx plus 2x sine y plus. Okay, then notice that all of that stuff is just this first term's derivative. Okay, because since it was x times y, we had to do product rule. We have to keep going through the equation. Plus 2y, what's the derivative? 2 dy dx, what's the derivative of x? And then plus 6, 0. Okay, then looking at all your guys, who's going to move across because they don't have a dy dx? Okay, it's going to come over here. So we're going to have 1 minus 2x sine y. And then on the other side, the only guys that are left over both have a dy dx. I'm going to factor that out. So my dy dx pulled out is going to be an x squared cosine y plus 2. And then we know that this is going to end up on the bottom of the fraction for dy dx. Are you talking about on this part? The reason why is because when we did product rule, remember u and v are the original pieces. You don't add the dy dx until you've taken the derivative. So in your original u, it's still an x squared. Your v is a sine y, and then when you take the derivative is where that dy dx comes in. Okay, if you write this. Okay, I just want to prep you because next week we're going to take your first quiz that's going to actually be for a grade. We've done a lot of practicing. Okay, if you have this on your quiz, this is wrong. How did this get to the bottom? What did we have to do to put it there? You have to divide it across on both sides. Okay, so for your homework, I know some of y'all don't care because it's just homework. Okay, but make sure for your notes that you're making an effort to like write stuff correctly so that when you're using them for your quiz, they're good. Okay, from there, I feel like you can do these other two pieces. Do you also feel like you could do those? Like write the equation, the tangent line, that stuff? Okay. One more that has product rule. Can you skip ahead for me, please? To number 7. All right, last one we're gonna do today. Number 7, will you need any product rule? On which term? X cubed and y, if they're together, you need product rule for that. So your u should be x cubed, your v should be the y. Oh, here it is. Hello. You do it already? Yes. Hold on. Now remember that these. Okay, so you did 3xy times y, that's the stagnant. Why aren't these together? These should be multiplied together, not like this. Did you forget to do the x cubed times the one? Yeah. Okay, good. You know, so yeah, add that in. Sure, when you do minus y, what's the derivative of that? 1 what? 1 minus 1 dy dx. Very good. Yes? Wait. Yep. Now you'll move this guy across. Then keep going from there. Good job. Yeah. Yes, that we are used to. What? They don't, they shouldn't cancel. We're just. So no, we don't have any more notes after that. Number 7. Oh, okay, yeah, so that's attached to the other.
And I'm saying I was here before. Okay, like drama.
Yes. Well, so this is your dy dx. In order to find the slope, so you need the other one. We'll do that part together. Yes. It's, well, you don't have to put it. It's x cubed times 1 dy dx, that's the same. You wouldn't have to like write the 1 specifically. Okay, let's see how you did. Last one, let's finish it up. Okay, your u prime should have been a 3x squared. Your v prime should have been a dy dx. Which means that your derivative should have been x cubed dy dx plus 3x squared y. Notice that is only the derivative for this front term. Okay, so for minus y, what's the derivative? minus 1 dy dx. No, you don't have to put the 1 if you don't want to. Equals 7. What's the derivative? 0. Thank you. Which term is going to move across to the other side? And if it was a plus, now it's a what? Minus 3x squared y. On the other side, my dy dx factored out is going to give me an x cubed minus 1. And then remember, we'll divide that to the bottom. So you'll have this. Dy dx equals 3x squared y over x cubed minus 1. Okay, let's finish out the last two parts of this so we can be finished. The next part says to find the slope. In order to find slope, look at your equation. What letters do you need? Just an x? An x and a y. And in order to have an x and a y, we have to go back to use the original. In the original, I know that my y is a 1. So I'm going to go back to my x cubed, y is a 1, minus y is a 1 equals 7. Okay, remember the original equation is the relationship between x and y. So x cubed times 1 is just a regular x cubed. How do I get rid of the minus 1? Okay, so that means that 7 plus 1 is now x cubed equals 8. What do we do from there? Cubic root. And then do we plus or minus on cubic roots? Just plus. So my x is a 2. Which means that not only do I know now my y is a 1, but I have the x that goes with it needs to be a 2. So then now to find my slope, follow your notation. It's dy dx, vertical line, 2, 1, and then you plug it in. For your homework, no, it's not necessary. For taking a test, yes. This notation would have to be there to label that it's the derivative and you're plugging in a point. That's just part of the notation. It basically means you're plugging in these values. Okay, so now let's look at our equation and sub those numbers in. It's a 3x squared y. So now it's a 2 squared y, and I believe there was a negative there as well. Okay, all divided by x cubed minus 1 would be 2 cubed minus 1. Okay, sorry, there's, I guess, no space if you write big. So what do we do first here? Do we do the 3 and the 2 is a 6 and then square? No, bad. 2 squared is? Times 3 is? Negative 12. Okay, then on bottom, 2 cubed is 8. Take away 1 is 7. Okay, let's write your equation of your tangent line for the next part. Okay, it's going to be y blank equals blank x blank. My point was 2, 1, written very clearly in my notation here. So if my x is a 2, remember I put a minus 2 in the parentheses. My y is a 1, I put a minus 1. And then my slope goes in the middle. Okay, then it asks you to plug in a value. We'll do that more next time. Okay, last little bit of this. We're only going to do the vertical slope. How do I find vertical slopes? That's the bottom equal to 0. What if I wanted horizontal? You do the top. So for the bottom, what are we setting equal to 0? X cubed minus 1. How would we solve that? Add the 1 across. And if x cubed is 1, do I do plus or minus when I take a cubic root?
No.
No. So the cubic root would just be x equals 1. So any point where my x is a 1, my slope would be vertical. Now, we are not going to do the horizontal, but in case you look at these for your quiz, I want you to put set top equal to 0. That way, in case you look back at it, you're not like, why didn't we do it? Okay? All right, you have about 15 minutes. Do not sweat this homework. We're gonna do more time on this next time. So finish a little bit more and then take a little bit. Jordan's is on today. Huh? You're welcome.